Hi, my name is Mike Warner, and this video is a draft sharing of some ideas I've been working on. And I wanted to start with this probably most existential question of our age of consequences that is being driven by the meta crisis that has been the dark side of all the benefits of our amazing economy. And it's the kind of grand, wicked problem of our era. And I want to establish at the start that this is not a video for people who prefer the left side of this diagram. We can have a debate about what the right side should look like, some kind of techno-ecological future, but we're setting aside the assumption, any kind of nihilistic considerations, and looking to see how can we best get to a better and brighter future. That said, having understanding where we are, and before we go into understanding where we can go, you can kind of break down human history in these sort of 5 blocks. They have distinct social organization and energy mechanisms associated with them each. Each of these lines corresponds to whole areas of evolution in systems that will need to be progressing. But where we're focused on for this conversation is this emergence of what I'd characterize as a holographic stage in the evolution of communication and what that means. And obviously you can talk about all these things quite a bit. And this is probably hardest to imagine, but it's so close, and it may happen in a sort of inflection point. Notice in this evolution that all these stages encapsulates it doesn't wipe out the prior stage, just like the evolution of the human brain from a reptilian brain. It encapsulates and builds on the prior stage. So you can kind of see a physical dollar bill kind of predates, it goes back to sort of early first governments. The printed bills came from China about 900 years ago, but you can see these as nested rings that are all interconnected, but different and distinct and evolving. And we're approaching this sort of planetary threshold where systems need to be internet scale, planetary. So that's where we are. And the thesis here that I'm going to share is this idea of an internet of everything. I think it should be holographic, and I think that protocol will enable a smarter enterprise when applied internally to groups, whether they're government or private sector, as well as what have traditionally been external industry and sort of national or even global scale systems will be improved. And so this follows is really the meat of it, and I've got 4 different themes here. We're going to talk about the geometry, the basics of it, to get you comfortable with this sort of new non-word or non-number based protocol. And then I'm going to introduce this sort of superpowers that come from it to get you a sense of that, and then discuss how it enables a smart economy, and then run through some architecture schematics for how it would be applied. So all that said, let's dive right in and start with the idea of geometry here. So an internet of everything has to deal with anything. So anything we're just calling A. That anything is in a context, that's everything. And our scope here is variable, but we're going to just refer to the world as sort of the ultimate omega. Even though you can go solar and galactic, we're not concerned with that here. We're concerned with the economy. So our everything will be the omega here. What's always been a challenge is this in between. It's what we have right now are data systems that fragment insights. We all have, in industry and financial services, for example, identifiers for different industries or companies, and those are all distinct and unique, and privileged or sort of private data associated with those. They're disconnected. What we're missing is a mechanism to connect all these things and connect global to local decisions and intelligence. And I'm going to propose that we start with circles and we work our way up through spheres into hyperspheres. And we use sphere packing and circle packing as a basic kind of graph paper for this new method. So right here, if you take 7 pennies, you put a penny down, and you'll find that you can only fit 6 around them, 6 pennies around it, and this creates a nice little grid in which you can create other grids. And what we're going to do, we're going to talk about how you can take any text information and map it into the circles. And once we've done that, then we're on our way to doing more sophisticated things. So just starting, we're also going to associate, you can see these are color coded, certain functions or certain positions in a circle of circles with certain functors that would imbue certain new powers, superpowers we'll talk about, including like agency for money. So also you see here like intelligence, we can build intelligence into an information unit. These holographic data structures will have artificial intelligence associated with like agents, and you can have multi-agent ecosystems and so on. But this is the start of it. And what we're really talking about here is just serialization. So whether it's a database or money in transit, between enterprises or individuals, or even at an economic scale, we can imagine using the serialization to sort of build new corporations that would, in a sense, augment our existing economy, make it better. So how do we do this? How do we take, here are the 36 basic digits, the zeros, 0 to 9, and then A to Z. We're going to take those, and just as this is illustrative, there's a lot of different ways you can do this. We're going to map them nicely. This is that's why I like this approach. You can map that alpha numeric series to 360 degrees and have plenty of room in between them all. And what you can then do is take any three and you can create a triangle. And we're going to start introducing basic conventions here. I'm going to argue that triangles corresponds to kind of a fuzzy conception of value. It's sort of a primitive, sort of the basis. And since you'll see a lot of these following forms will be derivative or expressible as triangles. And then if you take 4 points, you get a square. And that would correspond, you can think of it as a page or a row, row and a column combined, and data cubes. But yeah, the squares would correspond to intelligence. And then third amongst four sort of symmetrical shapes that are the sort of primitives. This is a weird one because it doesn't tile 2 dimensions. You can't have a symmetrical tiling with hexagons. They overlap, but you can combine them with other to make some beautiful things. But here we're going to use this for trust. So think of a pentagon as a trust primitive, which we'll combine with other things to create new things. And then finally, this hexagon, that's the last and probably the most magical, and we're going to reserve superpowers for that as we go forward. But that's got 6 points we'll talk about. So all these all have been talking about just 2-dimensional planes, and as you raise those up, there's a kind of additional dimensionality, obviously, as you go to 3 dimensions, 4 dimensions, and on the left you see what are called simplexes, like what is the simplest shape in each dimension, a triangle, a tetrahedron, a tesseract, and so on. And we're going to end up, we're not going to need all n dimensions, we're just going to use 8-dimensional hyperspace to create this new code that we're going to show in a moment here. But that's the basic sort of intro of how you get from text to these sort of hyperspaces. You don't have to worry too much about it. I'm just trying to give you a sense of how that's done here. So that brings us to this notion that we're going to be having these holonic circles that translate to holonic spheres that allow us to map anything relative to everything. And we're going to establish these kind of conventions here where you see what this is called the Blackboard font. These correspond to these simple exceptional Lie algebras we're going to talk about, which again, it's going to get fancy math, but you don't have to worry too much about it. But this you could consider to be a URL, like a format, like a www.html kind of codon that would allow us to build nested organisms of digital intelligence corresponding to physical systems and imbue them with higher intelligence. And you see in the upper part there, this is actually correspondent. Just as in 2 dimensions, you can have 6 circles around a central circle. In 3 dimensions, you can have 12 circles, and we're going to use all 12. But first here, we're going to start with 7 of the 12, corresponding to these A, B, C, D, E. We're going to talk about the properties of these as we go forward here. So each of those, once you dump text, and it could be a single name like Alice, or it could be a whole world like Wonderland, they're going to map into these texts. And you could do it manually or programmatically, and you get this ability to sort of translate any text, any string of characters into these geometric shapes and get these unique identifiers that will have functions related to each other that we can build and play with as we go forward. So let's dive in into this sort of sphere packing. And again, here you see a visual representation of the Lie algebras, the A through E. And then you saw also we're going to map additionally, because we're dealing with the planet, sort of the fundamental spheres of the planet that you would need for some kind of better accounting that will prevent this sort of environmental collapse we're facing and give us new tools for making that better. So coming back, we've got our circles that led to these spheres, and then each one of these spheres corresponds to these geometric primitives, and these are what are going to give us these superpowers. So we're going to now go to the superpower section and do a little introduction of what those could look like. And you're going to note that we're applying a sort of basic motif to each of these, a basic conceptualization that necessarily has to be fuzzy, but you'll see these patterns, whether you're talking about a squirrel or a world economy, living systems seem to have these properties, and these seem to work well. And obviously there's things to talk about here as we go forward. But diving in, just looking at the first, we're going to focus on AN, and the N means it's an infinite geometry. You can do it on any dimension. On the right, you'll see there's a SharePoint page that develops some of the ideas. Here, I'm just going to sort of dive into one articulation of that. I'm going to argue for this Satori concept, and that spells space, attribute, time, object, relation, insight. And what we're doing is we're going to identify those, and then we're going to use those identifications to map the data about anything into sort of awareness of what that thing is. And that awareness might be different than what it actually is, right? Because the system has to be fundamentally perspectival. But starting off, we have this sort of whole story where it's who, what, where, when, how, and why, the Aristotelian questions of interrogation. And these pretty much give you a good grasp or good handles on anything. So we're going to take those, and you see we've got some iconography for these that kind of invokes this sort of relationship between spaces and data about spaces and things and relations and insights and time. And by the way, all these properties are of anything, any entity, which is a broader concept, because these could be concepts as well, like inflation. But those then, once you can map any data about spaces or objects or relation between things, those map then to these geometric structures, which give you handles to connect them. So a single point can have embodiment in each one of these, either as the center point or as a point on the edge relative to something else, other center point. So all that established, you get this sort of solution to wicked problems where you can think of it as a complexity reducer, where any complex system can be expressed in these sort of fundamental ways. And once you have those handles, you're no longer stuck parsing text. You've got these geometric reflections of systems that let you do, will let AI especially do some pretty amazing things. And we'll talk about that. So coming back in, that's just the first sort of survey of the A, how to use that. And there's 4 total infinite graphs here. These are sort of the plurality and liberal sort of, anybody can have a perspective on anything. And now the B, you can think if A is like an awareness, B is like a being. So that would be your basic ontology or map, or I like to use the term atlas, which is a collection of maps. You can combine maps. You can have your enterprise map of the world, but why not leverage that industry or public economic map of that world and make them easily connectable? So you can think of this as kind of like a Lego approach, where a consistent nobbin using these geometries lets you connect any pieces from any kit you might have. So diving in, Again, this is like sphere based. All these things are sphere based, and then you're picking coordinates in that nested sphere space at the appropriate dimension, and you're building these things up. So you can start with your basic geometry, and then I like to think of the sort of scales. There's 7 here from like the world down to an individual, and you can think of those as sort of nested scales. And we can take those and we start to get this sort of economic atlas, this sort of digital twin of the planet, where if you like the OSI stack, it's like an 8th layer to that stack, where these geometric codons carry this definition of being that might be nested. It might be referring to a subset of a parent object, or interwoven or braided objects that are shards of larger objects. So on the right, you'll see I'm showing several ways of sort of slicing and dicing, but we can go already just with this sort of simple application of this B lattice to scale. We can start at the world where you see this sort of value, intelligence, and trust structures, and we can go into a country and we have sort of those functors as they're expressed at the country scale, and then we can unfold it and sort of drill into more granulated pixels, and that gets us to like states, for example, in the United States, and the associated trust, intelligence, and value there. And that's equivalent to like the industries in the private sector, and then you get down to corporations or agencies in the government, and there's your sort of next level down. And again, all these, if we saw back that hop vibration model I showed, they're all nested and interwoven in interesting, complex, and beautiful ways. And now we're getting down to the neighborhood, and then finally to like family and friends. These are the people like handshake distance, and then you finally get to yourself. And all these things are kind of nested. These holographic information structures will let us move more seamlessly through these. So you'll be able to define an adjacent space or see perspective or look out or look down through these data structures, and have handles for them that should be publicly addressable on distributed data systems, which we'll talk about in an implementation of this. But they're out there available. And I think this idea of a geometry and using geometry for the purpose is kind of the value proposition here. So moving on from B, and we may go a little quicker here through these because I'm trying to keep this video short. C corresponds to like a consciousness. This would be, and I'm going to use the term Gaia for global augmented intelligence architecture. This is sort of your Internet of Things on steroids, where it's not just things, it's also intent structures. Like if you take the will of all people who want clean air, that could be captured as an awareness construct that uses being construct to give guidance to cars, roads, trees on how to transact pico payments to offset or give accounting for systems that are currently being like taken advantage of. They're free riders. You have individuals taking excessive portions and in a manner that is not fair to. It creates social injustice. So again, we're focused on these sort of meta problems, but all these translate very easily to local problems. And this is Kate Bosworth's conception of the donut economy. And I'm going to use this to illustrate this sort of consciousness idea and sort of unpack what that is. But basically, you're either falling short. If you're poor, you're missing clean water or food or health. And those, we need to lift them up with a social foundation. And then there's other people who are living in excess, and they're out in the outer ring where they are currently abusing those things. They're causing air pollution or causing biodiversity loss. So imagine all of those outer things having a circle where we're mapping the best intelligence and making it available publicly to everybody. So kind of a consensus community, which we get to in the next D, with decision. Getting ahead of ourselves, though, but coming back, there's these decision matrices that give guidance on each of these. Those then become available through a network where they each have an address in that lattice associated with the C lattice. And so you see climate change, air biodiversity loss, each of those 12 things have a point in that shape, which can be mapped over here. Then we can shift our focus to the inside of the circle where things are falling short, and we can bring those out here, same way where they're each going to have points. So you end up with these loci or global to local data structures that allow individuals, organizations, enterprises, markets to map these systems coherently. And that leads to what we'll characterize as like a smart economy or a smart planet or a smart city. In an integrated fashion, all these systems have immediate abstract surfaces to find each other in a consensus based. There's no authority needed. You just get like, hey, we all agree that this is the best model for air pollution. This is the best guidance for it. All that kind of emerges. And then as systems evolve, all these things will work with current systems. But as newer systems evolve, as the economy makes this transition, all these capabilities will be able to sort of work seamlessly with all these smart systems. So coming back, that's C. Got one more left, the D, and I alluded to it earlier, where that's the decision. What is the right cost of pollution? How do you factor that? What's the best A, B, or C, whatever you want to focus on? And that corresponds to sort of I like to call them avatars, where it's not, you could have an avatar for a major corporation. They kind of exist, but they're kind of wonky. They're very analog with executives making decisions. But imagine sort of a holarchy enveloping the hierarchy, where the hierarchy still persists. It's like bones, but you also have more muscle in decisions where experts who are closer or reputationally attestated or role-wise would have more say in something. And that scales across, that's scale free. You can do it on any scale. But this D matrix that we're talking about, this across dimensions, is what we're going to use for that. And coming back to that Kate Bosworth donut, you can now think of each of those spots as a point of collective intent where anybody who's interested in any one of these topics can join a group that talks about these topics. And sure, we have these on forums on different social media platforms, but they lack a cogency, and this geometry added to all those things would allow that to be transcendent of a given platform. It's a sort of a standard, but it's super abstract, so you should be able to just add it in even the description field of any database. And that lends itself then to this sort of even visual representation of decision matrices, where you could have three-dimensional, and you don't need the three-dimensional, but they're very helpful representations of consensus. What are people agreeing to? What are they not agreeing to? How do different ideas connect? And what are those interdependencies? It's all sort of captured in these lattices. And now sort of shifting to sort of an illustration of that, let's look at, we've talked about climate, we've talked about equity, and then integral to both of those are sort of industries in the economy itself, which at a sector level in the NAICS has 20 different sectors. So we can imagine these each having an avatar. So finance and insurance would have a meta avatar of all financial companies that would be able to sort of own that avatar and be responsible for it, but also have account for it relative to other things. And those can have a geographic partitioning. Those lend themselves easily. Geometry, it's Earth maps into these things very readily, and you can sort of map them to each other, other sources from a geographic perspective. And as well, there's a granularity. You can get down into the taxonomy of chips, potato chips versus microchips, and there's 7 different layers to this. If you start at the top, and each of those can have a loci for consensus to be built. And then finally, you get this sort of network. It's not finally here yet, but there's a sort of interdependence and flow of goods between these, the NIPA tables. Those also translate to sort of a force mechanism that can be captured in this, where we'll have a better ability to cut down waste, because we'll have more transparency in systems, and tertiary, secondary, primary demands and needs will be better clarified. I think the last, we're getting sort of the data complexity, and this should make this easier to sort of align that and straighten it out. And again here, that those 20 industries map very nicely to the shape shown here, and those map then, you can imagine the climate, equity, and industry shapes, just even in 3 dimensions, overlapping, and being able to drill into each of those or connect them and fold them in different ways. But everything then has an address. It's a public address. It's a 0 point, in effect. Every holon starts with a 0 point, and then using that Satori, you kind of build up these address schemes, these 8-fold addresses, and then they all interconnect in ways they need to. And that kind of, to illustrate that, we're now getting to the smart economy so far. So that this is, again, just a kind of quick, kind of cursory view, and I want to get to explaining why you're bothering to maybe learn this way of looking at systems. But so far I've talked about this sort of Satori, like a holographic system awareness. Then this, where you could have, individuals and the planet having a kind of awareness. And they're obviously going to be different at different scales, but we lack things beyond kind of corporate or government. They're very limited, very fuzzy perceptions. They're almost blind relative to an individual's depth of perception relative to their environment. And then this idea of this being, this sort of whole system open digital twin, this global augmented intelligence where those systems are now intelligent. And then finally, you imbue the sort of superorganism with the collective consensus of individual participants relative to their domain. So we've got those 4, and we have this 4th industrial revolution, and that brings us to these last sort of 3 systems. They're less novel. They're digital currencies. They are systems of intelligence where embedded knowledge graphs are probably a good proxy for the geometric nature of information and how it's going to be shared between AI agents and systems. And then finally, this idea of open identity, where tessellations of different identity, a driver's license, biometric, will give people self-sovereign identities that can then connect in a privacy-preserving way with constructs that give them an ability to express their volition in a new way across these systems. And if we're watching these things emerge, we can think of this as kind of the composable enterprise, where enterprise in the sort of classic sense of not just a company, but just value becomes a surface. You're not going to have just a dollar. Any currency, we put CB in parentheses. It could be the dollar. It could be some currency for storage, like IPFS. They each can interrelate on these abstractions. And then also with intelligence systems, those different avatars serving like biodiversity and agriculture can mediate like their respective needs in the same language. And then finally, that sort of trust system where we will all be part of the global identity. You could just write down the number, I think it's like 8.3 billion, and that create addresses for all of them, and you tie it to like things like WorldCoin, and you're off and running to having a fabric that lets individuals be individuals, zip codes, cities, states, and even global personas or instantiations of their will. So there's all these systems now. We've got all these letters now. There's a quick sort of snapshot. And by the way, what's interesting here to call out is the A, B, C, D are infinite, meaning you can have them in 8 dimensions, 10 dimensions, doesn't matter. E, 6, 7, and 8 are unique to those 6-dimensional, 7, and 8-dimensional. And they have very fascinating topological relationships to each other and to the ABCD. So all of these are, in a sense, different illuminated sublattices of a meta lattice, where to sort of get to the punchline, you can imagine just putting the Earth in the middle of an E8, and then what all you're doing in crystallography, a crystal is just an instantiated lattice. So there's this lattice that we agree to, and central banks can agree to. They assign addresses to the 180 different central banks. Same with governments, and any kind of corporations. Each picks a location, and just as you would with ICANN, but you don't need ICANN here anymore. People just assert it and then consensually resolve. And through that ABCD, And then the E6, 7, and 8 emerge as the consensus resolution of the infinite will of individuals or corporations or governments. So I'm covering a lot there. Just sort of try to get through this, because obviously you talk a lot about this. Here's a representation of where we were and where we're going. It's this sort of nonlinear, open, continuous, sort of interconnected system versus the bifurcated systems. And here's a sort of depiction of how you would end up with this new smart economy, where literally any transaction could be in a context that is informed by the global set of considerations and superpowers that we've discussed so far. It's sort of like it's a lot on the diagram, but you get the idea, and it's all built off those simple Lie algebras and those geometries. So kind of coming back, I'm just thinking about different ways of representing this. Each of those then can be sort of described as like a meta model, like a meta coin. Like if the idea of meta is sort of a layer of abstraction up out of the data, like metadata, you could talk about a meta us for the D, meta markets for E, where any market asset should be findable or interconnected as we digitize assets with things like NFTs. That's the method they'll use. And then the meta model is getting into that C, that intelligence, where different assets can sort of combine and make derivative assets and explore that. I like this conception of MetaWorks, that we will know we will have arrived at a smart planet when we all, in effect, work for the planet. Whether it's through a corporation or just walking down the street and picking up garbage, we would magically be paid because we all kind of live in the planet. It's all of our home. And lacking that facility for a MetaWorks eliminates the potential for solving well-being needs of individuals. And so I think this is the key to helping a lot of those problems, making them simpler and more manageable. So focusing in now, I think we're getting towards the end here. I wanted to cover if you can pack 12 spheres around a center sphere, and that's been proven. What do you do with the other 5 if we've used 7 so far? And by the way, there's a total of 12 of these symmetric shapes, and I'm reserving others for other functions, which I'll talk about at some other time. But I wanted to touch on the sort of holosphere as it's applied to, historically, we had the lithosphere, the hydrosphere, the atmosphere, then the biosphere, and then the anthrosphere emerge. And these basically give account for what could be like an Earth bank, where you could use those A, B, C, D, E lattices to map, as you're going to see here, each of these worlds, each of these parts of the world, so that you can say effectively every individual on the planet has 3.4 trillion kilograms of Earth, or 128 acres of land surface, that is their, in effect, natural inalienable right. Therefore, then, once you start doing this, you officially have a counting of systems. You can say this person is overusing their proportion, right, or underusing, and that footprint has to factor in the primary, secondary, tertiary impacts of things they're consuming. For example, what's their Earth footprint? And then you can start using Pigovian incentives, like Pigovian taxes, methods to sort of weigh, incentivize good things and discourage negative things. And then just rotating that sphere. And again, this is like a holonic abstraction. It's a address, and they're going to get kind of fat, but you can use references and external data to have pointers. But we get about 160 billion kilograms of water is your natural right. And then just continuing that, we have a right to clean air. And it's fun to think about this. Like, how do you attestate that this 650 million kilograms of air is mine? You would start locally, and then you as close to possible to where you are. And then you would negotiate and partition the air as the people around you are sharing, and you end up with that sort of mapping where it's incentivized people to sort of attestate into these systems where they get their natural rights expressed and claimed, and would get their income derived from systems. Excuse me. So finally, the biomass is really critical, and the anthrosphere, it's the human sphere, and it's hard. That's basically the single unit for these measurements. So yeah, that's the smart economy now, where any transaction or any sort of economic activity can be done with instant access to global to local considerations that would give account of the ecological, the equity, and economic functors, where you would end up just calling this out. You'd have a world market where Amazon could participate, but anybody could lift anything and it just be on the meta market. It just appears. And that will open up a lot of potential and reduce monopolies and such. But now getting into sort of the architecture of implementing this, here's a schematic color-coded to this sort of schematic. And I'm just going to kind of go through each element. So first is kind of an overview of how this all fits together and how these topologically have a position relative to each other. And this is based on a friend's great research, but he makes a great case that I found very compelling, that to have something like this, all you need are 4 fundamentals: messaging, dissemination, equivocation, exclusion, and ordering. That's your basic. If you have those 4 things, you can choose your own variants of what I'm about to show here, where I would characterize the metaverse as sort of global brain or mind data structure that we will be able to see in 3D, and imagine like a 3D model, a higher dimensional model of the actual economy itself, as we showed earlier. That would be here with that protocol running on that. And once you have that awareness, you can start to get twins. You can say, oh, you're aware of the same object that I'm aware of, and therefore it's the same object, and we can sort of resolve that and get this sort of open cooperative governance. And this is where you start to get the emergence of digital currencies, new community financing, where a neighborhood can assert itself and get bonds based on that. And you also have this sort of intersectional democratic social networks where laws become more immediate and transparent. Like we could all decide that murder is okay, but we're not likely to do that. But we have that superpower. And all this stuff is built around sort of democratic instincts that authority comes from the will of the people. And then you finally have these kind of cooperative ecology, equity for the commons. That's those conscious avatars for the social good are starting to emerge with the being. And then you actually get them expressed here. And for these, and you have to be able to enable consensus-free systems in order to have consensus. And that's expressed there. And then you have the open public utilities for governance. This is constitutional governance. There has to be Sybil resistant. You have to be able to prove in the system that every person, agent, every person is a person, and every agent is known. In effect, it has to be at a state. It has to be proven that it has to be Sybil resistant, and that's that agent layer. And then you get into digital entity architectures. That's a sort of meta market where price has to be transparent across the system. That's a digital entity. And then there's the DAO type model, the distributed autonomous organization, has to be built up off that consensus-free potential up from that. And then getting close to the end, I think that's pretty much the end here, where starting with on the far right corner over here, you have points, circles, triangles you build up, and you can apply those each across these dimensions, where like a circle becomes a sphere in 2 dimensions and so on. This is like a matrix. And you have value, intelligence, and trust associated with these. You associate those with these lattices that correspond to those geometric shapes. You end up with this sort of digital twin potential, where you now have a digital twin, and then you can have avatars defining functions in consensus-free, consensus-based contracts on the twins, and it's I got the coloring off. Those should be black in a more final version of this. I'll do that, and that should help us lean over on the left side here. That should hopefully avoid the wrong or the right side of this presentation. So that's 40 minutes. It looks like I'm going to hit that on the dot. Thanks for paying attention and appreciate it. Love your feedback, thoughts before I record another version. Thanks.